So the focus of this lesson is on factoring our polynomial over the complex numbers, and the only information we're given is that we have a 0 of 1 minus I. Now that is an imaginary 0, so even though we're given that single 0, we're technically given a second 0, its conjugate. And it'll have the same real part but the opposite imaginary part, so it'll be 1 plus I. And so at the end of the day I have 2 of the 4 zeros, and the reason I know that there's 4 zeros is because the degree of our polynomial is 4. So if I can get the remaining 2 zeros, then I can basically factor this over the complex numbers. So for now, I'm going to go ahead and list the factors that I do have. And remember, whenever you're given a 0, you automatically have the factor. All you have to do is take x minus that 0. So x minus 1 minus I, make sure that's in parentheses, x minus 1 plus I, make sure that 1 plus I is in parentheses, and then that way I know I need to distribute my minus sign. So at the end of the day I get x minus 1 plus I, x minus 1 minus I as my two factors. Now if I go ahead and multiply these together, I can basically get a quadratic that evenly divides into my original polynomial. And what I would do is I would end up performing division to find the remaining quadratic that I can eventually factor down and find its zeros. Either I could factor it down or maybe use a quadratic formula. So that's what we're going to work on next. Now, whenever I'm multiplying these complex conjugate factors together, it's helpful if I group the real part and keep the imaginary part separate. And then I basically FOIL, and I FOIL according to the way I've grouped. So for first, it's going to be that group x minus 1 times the group x minus 1. So it's kind of like I have foiling within foiling. And then outside it'll be minus x minus I times x minus 1, positive I times x minus 1 is my inside, and then last would be minus I times I. So for the first I will have to FOIL again, but when I FOIL this, I'm just going to go ahead and do it. It's going to be x squared minus 2x plus 1. And then the outside and the inside will always, if I've grouped it this way, they're actually going to cancel out because they're just the same but opposite in sign. And so they'll add out to 0. And then for that last piece, you'll do negative I to the second, but I to the second's negative 1, so it's negative negative 1, which is just a positive 1. And so if I put those pieces together, we can see that this multiplies to x squared minus 2x plus 2. So this x squared minus 2x plus 2 is a factor of our original polynomial. So then now what we can do is we can take that x squared minus 2x plus 2 and divide that into our polynomial to get the remaining quadratic. So I'm going to go ahead and do that now. So it'll just take me a second to write the division down here. And you do want to be careful with all your signs whenever you're doing long division. And the reason I have to do long division is because that is degree 2 factor that we're trying to divide in. It's not degree 1, so I cannot do synthetic division. And so if I take x squared into x to the 4th, it goes in x to the 2nd times. Multiply, I'll get x to the 4th minus 2x to the 3rd plus 2x squared. I go to subtract, I draw the line, and I change my signs from what they originally were. And my degree 4 and degree 3 terms add out, and I get negative 1x to the 2nd. And then I go to bring down my next, actually I can go ahead and bring down my next 2 terms. And then x squared into negative x squared goes in negative 1 times. And I'm just lining it up. So negative 1 times x squared is negative x squared, and then plus 2x minus 1. And I go to draw the line and I change my signs, and notice they're all oh, and this is 2, so oops. Notice they're all opposite and they add out to 0. And so we can see that our original polynomial p of x is factored into x to the second minus 2x plus 2, but then the other factor we get is the x squared minus 1 that we got from the division. And that's a difference of squares, so we can actually factor it further. And so when we factor it further, we get x plus 1, x minus 1, because the x is squared and then 1 is squared, and you do x plus the 1, x minus the 1. And so at the end of the day, we're trying to write this in factored form over the complex numbers. So now we can take that our original factors for this quadratic and keep the linear factors that we originally had, which were x minus 1 plus I, x minus 1 minus I, and then we have that x plus 1, x minus 1. And so this completes the factorization over the reals, or sorry, over the complex. And you're basically done. As far as the actual zeros, we can see that negative 1 and 1 are the remaining zeros of the 4 zeros that we would have had. So